celebrate the 20th birthday of the Linux kernel. Now I'll give you a warning that a lot of the history you're going to hear today comes from my rather aging mind, and that I have an increasingly hazy memory, and it's not guaranteed to be exactly accurate or even completely complete. So if you're going to have a problem with this, you can leave now, but otherwise I think you'll find it an interesting and entertaining talk. Now, I'm going to go back in time, this talk, because I'm going to go back to the first use of Unix, and actually the first use of Unix in a protective security environment was in Istanbul in 1453 AD. There was a person by the name of Mehmed the Conqueror, and he had a harem of women, and he used Unix to guard his harem. He had white Unix, and he had black Unix. Well, maybe it wasn't spelled UNIX, maybe it was spelled differently, but they were Unix nonetheless. Now, when we want to talk about free software, we have to talk about the real conception of free software. We have to go back to a birthday, talks about the birth of the child. But that starts with the conception of the child. And we all think of free software as something like this, Tux with the penguin with pasted up glasses. But when I was a student in 1969, I was actually using what we might call free software. That was because in the period of 1943 to 1977, computers were rather huge and expensive. The first computer that I ever programmed was an IBM 1130. It ran one program at a time. It basically had no operating system. You linked your device drivers directly into your program, and then you ran your program inside the machine. Those are lights up there that could tell you what was happening inside the machine, as well as sense switches that you could set that would control how your program works. Now, this had all of 4,000 words of memory, and it had a it had a 5 megabyte hard disk drive, and this machine probably cost about $1.5 million in 1969. And that's when $1.5 million was a lot of money. Now, most application software of that time was written in source code because there weren't enough computers of any architecture to justify creating a binary distribution. So you got the code in source and you compiled it. And if it was software that you purchased, you would have a contract that you would sign that would say, I'm not going to put this code on anybody else's computer. But basically, because you had the source code, you could change it, you could fix your own bugs, and you could extend the software the way you wanted to. Now, I'm going to talk a little bit about a myth that is in the present-day computing industry. And that's the fact that computer vendors try to lock in customers to their system by creating interfaces that were different from every other vendor. Believe me, folks, I was there. It didn't happen that way. We didn't sit around the room saying, oh, let's create this new interface that locks the customers into our computer. We were simply trying to create operating systems to let people use the computer to their maximum advantage. Because remember, compared to today, these machines were incredibly slow and had very small memories. So you wanted to, and they were very expensive. So you wanted to make them as efficient as possible for that particular job mix. So if you had a computer that's going to be used for business, then you would orient it towards COBOL and batch processing, because that's the way that business worked back in those days. If you wanted to do scientific work, you would orient it towards Fortran, and you might have a time-sharing system. because that's how engineers worked back in those days. Or you would have something that was a real-time system, because engineers needed that to control circuitry. So we designed these different operating systems to take maximum advantage of the hardware. If you could make the problem work 10% faster on a $2.5 million computer, that means it's worth, the solution's worth $250,000 to you. It's worth it, okay? And if it was true that we really were trying to lock people in by having different programming interfaces, then digital would not need 11 different operating systems on their PDP-11 to meet different needs. They could have locked their customers in with only one operating system. So I just wanted to clear that up and get that out of the way. Now, as I said, free software did exist back then. I was a college student in 1969, and I didn't have 100,000 US dollars to buy a commercial compiler. So there was this organization called DECUS, the Digital Equipment Corporation User Society. There were other ones like IBM Share, HP's Brainstorm, you know, different ones. And they would have customers who would write software to try and use these computers. These people were not professional programmers. These people were doctors, educators, scientists, farmers, lots of different people that would write software for their own use. This, by the way, sorry about that, go back. That is the second computer I ever programmed, a PDP-8. That had 4,000 words of core memory. A couple years after that, I bought 64,000 words of core memory, and I paid $128,000 for it. So you can see that even though this is a tiny little computer sitting on a desktop, it's still pretty expensive. And so I would send away to DECUS for a piece of software. I would pay $5 to have a paper catalog sent to me, and once I looked through the catalog of software, I might see a nice text editor for $5, and I would send away for it. Now, $5 back in those days was still a lot of money, because $5 would buy you 5 pitchers of beer. And I think that you would know that as a college student, you might have a conflict there, right? Text editor or 5 pitchers of beer. And I think you can see where I went, you know. But the nice thing was that this was free software. So once I got the original paper tape that would hold the text editor, I could go to the school store, I could get some new paper tape, put it in my ASR 33 teletype, and put the tape I got from DECUS there, and it would automatically copy it. And then after I made 5 copies of it, I could sell it a copy apiece for 5, you know, to my students, to my roommates, and I could make back my money. So I could have my text editor and my 5 pitchers of beer. Because they were paying me for the service of making this editor for them. First of all, I tested it out to see it was a good editor, that it did what it was supposed to, and then I made the copies. And that was the service that I was providing to them. And this is a lot of what we do with free software today. Now, a lot of people would say, why didn't they sell the software? Well, selling software is very hard. You have to test the software, you have to have documentation for the software, you should give support for the software. And these people were not professional software makers. And they had their real job to do. They were just writing the software to help them do their job. And then after it was written, they said, maybe I can give it to help somebody else. And then maybe when I go to a DECUS meeting, somebody will say, great piece of software, it really helped me out. Or great piece of software, let me help you make it better. Or great piece of software, let me buy you a beer. Or great piece of software, let me buy you dinner. Or let me give you a job. And a lot of these reasons are the same reasons why we write software today, free software. Oh, by the way, I found a piece of that paper tape recently, and I calculated out how much it would be to store 2 terabytes of data. And it would be 10,112,360 kilograms, and it would be 72,853 kilometers long, and it would take about 6,000 years for the ASR teletype to read it in. So we just threw that in there. Now, in 1969, in New Jersey, there were these 2 people at Bell Labs, Ken Thompson and Dennis Ritchie, who decided to write this little operating system called Unix. And they wrote it on a cast-off PDP-7 computer. This was something that was lying out in the hallway, and they pulled it into their lab, and Ken started to write Unix just for fun, just because he wanted to play this game called Space Wars that he liked. And he started to write his operating system, and other people from Bell Labs started to join in doing this. And the PDP-7 was a mini computer. Its price was still fairly large, but it was reasonable for the time and for the use of Bell Labs. Now, Unix was one of the first operating systems that was written to be portable. It wasn't written to be portable originally. It was written in assembly language for the PDP-7. But as the PDP-7 tended to be too slow, they went out and found a PDP-11. And when they ported it from the PDP-7 to the PDP-11, they had to rewrite the entire operating system in assembler once again. At that point, Dennis Ritchie said, this is too much like work, and he invented the language C. Then they rewrote the operating system again in C to make it what they thought would be portable. But then they put it into another computer, and they found out that it really wasn't as portable as they thought. So they rewrote the operating system again into 2 parts. One was the same no matter what system you put it on. It did scheduling, memory management, things like that. And the other part was what they called device dependent. It was the device drivers and the things that were specific to a particular computer system. As they ported it to more and more machines, they got better and better at making the operating system design portable. Now, the reason that being portable was good was because if you could have the same operating system on different hardware architectures, on different computers from different companies, that meant you didn't have to retrain your users every time just because they were using a different system. And you didn't have to do massive changes to your programs to get them to work across these different systems from different vendors. One more thing happened in 1969, little noticed by anybody except 2 people, Linus's parents. Linus Torvalds was born in Helsinki, Finland, and we'll see more about him later. Now Unix started to spread because they would give away. We turned the amp down a little bit. We started to get taken to universities because universities liked seeing the source code. They liked working on this little operating system, and they started to help make it better. But Unix was not free. You had to pay the telephone company a license fee for it. And if you were not a university, if you were a company, or if you were a small technical college like I was at, it meant you had to pay $160,000 US to get Unix. Remember, this is 1969. That much money, you could buy a very nice house. In fact, you could buy 3 of them. Now, if you wanted to put Unix on the second computer, it was another $160,000. On a third computer, it was another $160,000. This was a telephone company. They did not understand volume discounts. So then you would send away for this magnetic tape, and you would get it. But along with the license, it said, if you let your students take a look at this source code, they could become contaminated. And if they went to work for another company trying to rate another operating system, and they inadvertently used some of AT&T's code or intellectual property, you could be sued. So Unix was not a free operating system. In addition to that, it went to the University of California, Berkeley, where they started working on a completely different kernel. It had a lot of the same portability and features of the kernel from AT&T, but they were actually doing a better job of creating this kernel than the people at AT&T. Now, about this time, commercial vendors started to make commercial versions of Unix. And to get around the issue of having to pay $160,000 per CPU, they were creating binary-only copies. Because AT&T said, if you ship only binaries, you only have to charge $350 per CPU, not $160,000 per CPU. So these companies started to produce binary-only copies and send them out to their customers. But they didn't even call it Unix. Sun Microsystems called it Sun OS, and later on Solaris. Digital Equipment Corporation called it Ultrix, and then later on OSF1, and after that Digital Unix. All of the different Unix systems had different names, and when a customer came up and said, I want Unix, Sun would say, here's Sun OS. And the customer would say, no, I want Unix. It was very confusing. And eventually also there were some wars between different factions. Sun and AT&T on one side, calling themselves Unix Systems Labs, and the Open Software Foundation being made up of Hewlett-Packard, IBM, and Digital Equipment Corporation. And much stress was happening because of these wars going on. About the same time, 1977 to 1983, IBM was coming out with their IBM PC, and Apple was coming out with Apple II. CP/M was already there. All of these were binary-only distributions. And this was causing people to get away from using and understanding how to use source code and shipping source code. People became more and more used to it. Computer stores started to appear. Now, before this, you wouldn't have a computer store. There were no computer stores before 1977. Because if there were, you would need an 18-wheel tractor-trailer truck to haul your computer home. You need 3-phase power to plug it in, and you need a 20-ton air conditioner to cool it. But after the PC and Apple II started up, people could go to a computer store and buy not only their computer, but boxes of shrink-wrap software to run on them. Now, there was one person who objected to all of this. His name was Richard Stallman. He was a student at MIT. And he really liked looking at the source code for operating systems, and he liked having the operating system, and he decided to write a complete operating system in source code form, and to make it freely available to people. Now, he could have started writing the kernel first, but that would have been a recipe for disaster, because there have been a lot of people who would contribute to that, and after maybe 5 years, they would have nothing to run on top of that. So he took a different strategy. He wrote software that would go on top of the operating system and be useful. And he would deliver that software in source code form, but with the goal of having a complete operating system eventually. So the first program he wrote was Emacs. And there are some people who say he could have stopped with Emacs because Emacs is like an entire operating system. But he wrote Emacs, people like that, and then he went on to create the GNU compiler suite with GCC and Fortran and other languages, people like that. And more people started helping him with this task of writing this complete operating system. And of course, there were other things out there that were freely available. Berkeley software distribution from the University of California, Berkeley was available. SendMail as a mail transport system was available. The X Windows system came from MIT, a project called Project Athena. And all of these were free software under different types of licenses. The birth. So if you remember, in 1969, Linus Torvalds was born. In 1991, he was now a university student at the University of Helsinki. And he had gotten a brand new IBM 386 PC. And Linus was a very smart student. And he knew that the operating system that came with that brand new 386 PC did not take advantage of all the features of the Intel processor. Now, to be fair to the company that made that operating system, and I won't mention what their name is, but they were still trying to support the 286, the 186, and these systems did not have the main feature that Linus was interested in, demand page virtual memory. So Linus knew that there were systems out there that took advantage of that, specifically Unix. But all the Unix systems that were out there were too expensive, and they didn't come with source code. So Linus decided he was going to write the kernel, do the kernel project just for fun. He didn't expect to be anything big or fancy. He just said, I'm going to do this just for fun. Sends out an email message across the net, and other people start joining in and started working with him on this project. In the period of 1993 to 1994, the kernel was getting fairly good. And we were beginning to have beginning distributions come out. One called SOS, Soft Landing Systems, was one of the first distributions, followed by Yggdrasil. Now these two distributions and Transameritek no longer exist. They were a little bit too early. They got diverted. They lost funding. However, one, Slackware, is still in existence today. And it's a very, very good distribution put out by somebody named Patrick Volkering and a staff and a crew of volunteers that work on that. Now, in early 1994, the kernel was good enough to become version 1.0. It still isn't like the kernel of today. It was single CPU. It only ran on Intel. It didn't have any log-based file systems, but it was good enough that you could create an entire distribution, and other distributions started to appear, like Red Hat and others like that. Now, in May of 1994, we were going to have a DECUS meeting in New Orleans of the United States. I do not know how many of you have ever been to New Orleans, but it is the adult Disneyland. You can get anything you want in New Orleans, and a lot of things you don't want. But a certain gentleman by the name of Kurt Riesler was the head of the Unix Special Interest Group, kind of like a lug, inside of DECUS. And he had heard about this person in Europe and this project, and he wanted this person to come to DECUS to talk about it. And he kept sending out email messages to all of these small companies that I mentioned and said, would you please help us fund this trip? And he would copy me on these email messages. And these companies would write back and said, we're very small, we don't have any money, but we'd be happy to give you CDs to give out to your members. After a while, Kurt was almost ready to give up. And I liked Kurt. He had good ideas. So I went to my management and I said, I don't know who this person is, I don't know what he did. But I think, because Kurt has good ideas, I think we should fund this. And my management went to their management and they said, we don't know who this guy is, and we don't know what he did, and we don't even know who Kurt is. But Mad Dog sometimes has good ideas, so I think we should fund this. And we got $5,000 US to fly this person from Helsinki, Finland to New Orleans. And then Kurt asked the really horrible question. He said, I need an Intel PC to run this software on. Now, I worked in the digital Unix group, and we supported VAXes, and we supported MIPS processors, and we supported alpha processors. We didn't support those weak, miserable, crappy Intel PCs. But I got him one. I sent it down there. I flew down to New Orleans. I saw Kurt trying to install the software and having problems. And along comes this nice young man wearing glasses, sandy brown hair, wool socks with sandals, and said, can I help you? And Kurt says, yes, I think you can. And 10 minutes later, Linux was running on that PC. Now, this was the first time that Linus Torvalds had ever installed Linux off a CD. The way he installed Linux was to build the distribution on his second hard disk drive, boot that, and install it on his first hard disk drive. His PC didn't even have a CD-ROM. And they invited me to sit down and to try this out. Now, I am a fan of pianos and piano music. And I will tell you that when you play a piano, if the piano is well tuned, you usually can get fairly good music out of it. But if you play a really, really good piano, all the keys are perfect and weighted. And it is a pleasure to play that piano. This was like this operating system called Linux. Because I had used many Unix systems in the past. But when I used this, everything was in the right place. And it was like playing a really great piano. And even on a weak, miserable, crappy Intel PC, it still responded very nicely. And so I said to myself, what would happen if we took this operating system and ported it to the Alpha, a 64-bit system, the fastest microprocessor in the world? And I got this idea that this operating system could actually be used for research in universities into large address spaces and how to use them. Now, for those of you who have never thought about this, a 32-bit operating system could hold 4 billion bytes of data in virtual memory. And that seems like a lot, unless what you're trying to do is edit the Lord of the Rings movie. Or you're trying to simulate a Boeing 747 airplane over its entire life. Or you're trying to do global warming studies. Then all of a sudden 32 bits becomes amazingly small. But 64 bits is 4 billion times 4 billion. That means you can store a gigabyte of data every second of the day, every day of the year, 24 hours a day, for the next 5,386 years, and still not run out of address space. Or you can store 128 bytes of data for every square millimeter on the surface of the Earth, including all the oceans. It's a lot of data. And so I took Linus out on the Natchez, this steamboat, and we went up and down the Mississippi River drinking this wonderful drink called a hurricane. Now, a hurricane is so powerful as an alcoholic drink, after you've had 2 of them, you feel you've been hit by Katrina. And we're going up and down the river, and I said, Linus, have you ever thought about porting Linux to a 64-bit system like the Alpha? He says, yes, but they've been having trouble getting me one of these systems in Helsinki, and I might have to do the IBM PowerPC instead. And somebody told me that I actually dropped my drink on the deck of the boat, and I never drop a drink, ever. And I said, don't do anything rash, because I'm going to get you that alpha system. This is Litas back in 1994 going on board the Natchez, along with an unknown person. Okay? Now, people would tell you in business that the way you get some type of project done is that you write a proposal, and you put down the justification, and you send it to your management, and they read it, and they ask you questions, and you change the proposal, and you reread it, you rethink it, and then it's funded and budgeted and stuff like that. No. The way you get things done in a large corporation is you pull in favors. And I've been in digital for 16 years, and there was a lot of people that owed me favors. So I called up my friend Jim Jackson, and I said, I need an alpha system sent to Helsinki, Finland right away. You don't know who this person is, and you don't know what he did, but I need that system. And Jim said, I happen to have one. 96 megabytes of main memory. Remember, this is 1994. Memory didn't cost $10 a gigabyte in 1994. 96 megabytes of main memory, 21-inch monitor with a 3D graphics card. It had a 4 gigabyte hard drive and a CD-ROM, 4X CD-ROM in it. The whole system cost about $30,000 US. And Jim said to me, what are you going to pay for? And I said, I'll pay for the shipping. And then it got to Helsinki, Finland, and we realized we made a strategic mistake. We said it belonged to Linus instead of belonging to digital. So the Helsinki office had to pay $15,000 in duty to give it to Linus. But he got his alpha system. I went back to my management finally and gave them a presentation about free software and Linux. And they said to me, why did you do this? And the last bullet on the last slide said, because Linux is inevitable. There's nothing that can stop it. And my management laughed at me. Today, every single one of those people works for Red Hat. Now, we started the Alpha Linux port in January of 1995. And I started to find out what the word community meant. People in the community went out and spent their own money to buy alpha systems to help with this port. Particularly people like David Mossberger Tang, who helped to port the math library of Linux. And Richard Henderson, who single-handedly did create shared libraries for Alpha Linux, something that 15 engineers working at digital for 7 years had failed to do. He did it by himself. I began to see what community could do because in 9 months, these people who had never met each other face to face had taken Linux from a 32-bit system, only Intel, a CISC processor, to the Alpha, which is a RISC processor and 64 bits. Now, in 1994, the world was having a problem. Supercomputer companies like Cray and ECL were starting to go out of business. They would spend millions of dollars to create a supercomputer, and then they would sell 5 of them. And they weren't making enough money to keep in business. Now we need supercomputers for lots of things. So 2 people, Dr. Thomas Sterling and Donald Becker of NASA, decided that they were going to create a different type of supercomputer. One made up of those weak, miserable, crappy PCs, all hooked together with high-speed networking, and they called this concept the Beowulf system. And they found out that the Beowulf system could actually create the computing power of a mainframe supercomputer for 1/40th of the price. We're looking at it another way. For the same amount of money, you could get a supercomputer that was 40 times more powerful than the proprietary closed supercomputer. But, as a friend of mine named Pat Goda said, the real power of the system was that you could actually get applications for it, because it used the same kernel that runs on my notebook. And the interfaces were the same as on my notebook. So actually you can get OpenOffice to work on the supercomputer. And this started to spread. Now what types of applications are we talking about? Image rendering, making movies and things like that. Image recognition, looking at photographs and determining what's there. Weather forecasting and global warming. Data mining is one of the biggest things that is used in the genome research was MySQL.